Welcome to Structural Engineering Online. In this video lecture, we will learn how to calculate support reactions of an overhanging beam. Please subscribe to our channel if you have not yet subscribed. In this lecture, we will solve the problem of support reactions for an overhanging beam. In the case of overhanging beam, we find that there are two supports. One is hinge support at A and other one is roller support. But here the difference between overhanging beam and simply supported beam is that there is some overhanging portion here. You can see this overhanging part here, which this is overhanging. This part is not supported here. So we can say that this is just a combination of our simply supported beam and a cantilever. So the portion from point B up to, you can say if this is point C, from B to C can be considered as a cantilever, and from A to B we can say that it is just like simply supported beam. If you want to see how to calculate the reactions of simply supported beam, you can see our previous lectures. There are video lectures available and you can get the benefit of those lectures, how to calculate the reactions of simply supported beam. Now here, first of all, we will see how many reactions are possible for these supports. Hinge support, as we know, will have two reactions, one vertical and one horizontal, HA, VA, and this roller support will have only one vertical reaction. Okay, so there are only two supports. So on these two supports only you will have the reactions, at no other point. Then to solve for these reactions, we have those equations of equilibrium, which we have sigma fx equal to 0. So here is the solution of this problem. And when we say that sigma fx equal to 0, we have only one reaction here and there is no applied force. So for maintaining the equilibrium, this HA will be equal to 0. And then we apply second equation of static equilibrium, which is in y direction, sigma Fy equal to 0. That means algebraic sum of all the forces in y direction should be equal to 0. So in y direction we have VA and VB acting in the upward direction. This point load is acting downward and this 3 kilonewton per meter is acting downward. So we have to apply that sign convention which we have already learned. So we can say, okay, again I will remind you about that. Horizontal direction, which is x direction, we take right hand will be taken as positive, and in vertical, which we call as y, upward forces will be positive and downward will be negative. Similarly for the rotation or the moments, this anti-clockwise will be taken as positive and clockwise will be negative. This is our sign convention which we have used in our previous lectures. Also, we write these values of the forces in y direction. So plus VA plus VB, these are the two unknown reactions. Then the forces which are acting on the beam minus 2, this load, and then we come to this UDL, which is minus 3 into 2. These are the forces which are acting. So we can say that VA plus VB will be equal to 8. Okay, so this is your equation number 1. Now we can take the third equation, which is sigma m equal to 0. So in that case, we take the moment about point A. That will be easy for you because these two forces HA and VA are acting at point A. So they will not have any moment. VA will be automatically removed, eliminated. So VB will give you the moment and 2 kilonewton will give you some moment and this UDL will give you the moment. So we start with this extreme load which is 2 kilonewton, so moment of this 2 kilonewton, and here we will follow the sign convention. Look at this load acting at C, and this is your point A. This 2 kilonewton load will try to rotate our beam like this, which is clockwise direction, and clockwise direction we have taken as negative. So the moment of this 2 kilonewton force about point A will be 2 into 6. The distance of this load from point A is 6. So we write here minus 2 into 6. Then we look at this reaction VB. VB is acting at a distance of 4. So if we look here for VB, this is point A and VB is at a distance of 4. It will try to rotate the beam in this anti-clockwise direction, and so anti-clockwise we have taken as positive, so VB into 4. Now we have this third load, which is uniformly distributed load over a length of 2 meter, and what it will do, we have here only this much, 3 kilonewton per meter, and the length is 2. This is your point A. So in that case, in the case of UDL, which is 3 kilonewton per meter, total load of this UDL can be taken as 3 into 2, because for 2 meter and just for 1 meter the load is 3 kilonewton per meter, so for 2 meter it will be 3 into 2. Now to take the moment, we must find where is the center of this UDL. It will be just at a distance of 1 meter from A. So total load is 3 into 2 and it is acting at a distance of 1 meter from A. So we can easily take the moment of this load, which is, and also it will try to rotate in the clockwise direction. So it will be minus 3 into 2, which is the load, and the distance of this load from point A is just 1, and this whole thing equal to 0 for equilibrium. Now we can say that 4 VB is equal to, it is 6 into 2, that is 12 on this side, and 3 into 2, it is also come here 6. So we can say that VB is equal to 18 upon 4. Once we get the value of VB, we can easily calculate VA by substituting the values here in this equation. So VA plus 18 upon 4 is equal to 8. Then we can calculate the value of VA, that is 8 minus 18 upon 4. So 8 minus 18 upon 4, and you can say, okay, this will be equal to 32 minus 18 upon 4, which can be 14 upon 4. So this way we get, if you want, you can also simplify. This will be 4.5 and this will be 3.5 kilonewton. So this way we have calculated the reaction. So you have found that here also we are applying these equations of equilibrium for the calculation of support reactions. Thank you very much for watching this video. If you like this video lecture, please share it with your friends and also subscribe to our channel so that in future when we upload new video lectures, you will get the notification. Thank you very much.